Since we just learned about a circle, there is an other conic section. Those of you who studied this in 11th and 12th grade would know what an ellipse is, right? Those of you who have not studied, it's okay. So this is a very, very simple idea called an ellipse, right? So ellipse is like your egg-shaped thing. So suppose, imagine, let's look at it in 2D first, okay? As usual, we'll extend it to 3D and high-dimensional space. Let's assume I have I have two dimensions, x1 and x2. Let's also call x2 as y and x1 as x. Okay, an ellipse looks like an egg-shaped thing here. Of course, I didn't draw it properly. It's symmetrical both on x1 axis and x2 axis. Let's assume the center of this ellipse is origin, right? Then this is called the minor axis, and this length is called b. This length is a, right? Then we can write the equation of the ellipse. For those of you who have never seen it, it's okay. It's okay if you have not seen it. Probably this could be the first time that you're seeing it. Those of you who have studied this in your 11th and 12th grade or undergrad first year would quickly understand what this is, right? The equation of an ellipse is x square by a square plus y square by b square equals to 1, right? So this is the equation of an ellipse in 2D, right? So of course, if a point lies, again, an ellipse also breaks up your 2D space into two regions, one inside the ellipse and one outside the ellipse. In machine learning, we don't use ellipses as much. We mostly use planes. Most extensively, we use planes, but we also use circles sometimes. We seldom use ellipses, but I thought I'd explain this so that you get a understanding as well as an appreciation of how beautiful linear algebra is, right? So this is 2D, and of course, if x squared by a square plus y square by b square is less than equal to 1, right? So let's assume I have a point here, x1, y1, right? If I just put these values in this equation, if the value is less than 1, then this point P lies inside, then P lies inside my ellipse, or this ellipse, inside this ellipse, which is centered at 0, 0. This is called the major axis length, half length of the major axis. This is called the major axis. This is called the minor axis of an ellipse, right? If the half the length of a major axis is A and half the length of a minor axis is B, then if this is less, it lies inside. If it is greater than 1, it lies outside. Then P lies outside my ellipse. If it's exactly equal to 1, then it lies on the ellipse, right? So this is my 2D. Now let's just extend it to 3D. What is the equivalent of a 2D ellipse? It's called an ellipsoid. Ellipsoid is literally like your egg-shaped thing, right? Ellipsoid is basically, it's hard to draw it here. So if you have three-dimensional surface like this, x1, x2, x3, right? Just imagine a three-dimensional egg-like structure, or a soccer, or a ball which is stretched like this, which is stretched horizontally. So you can take a simple football like this, and if you stretch it horizontally like this, what you get is an ellipsoid, right? If you just stretch it on both sides equally, then what you get is an ellipsoid. I think the rugby ball sort of looks like a ellipsoid. I'm not very good at sports, so please bear with my misuse of terms. If it's not rugby, please excuse me, but I think it's a rugby ball. Of course, it may not be symmetrical again, but as usual, let's go back to the math, because that's what we're concerned about. So the math for the equation of a three-dimensional ellipse is called an ellipsoid. A three-dimensional ellipse is called an ellipsoid. And the equation for that is again straightforward. It's x1 square by a square plus x2 square by b square plus x3 square by c square equals to 1. Here again, a is the length. A is the length on x1. A is this length. B is this length, and C is this length, right? Now it's basically your semi-axis lengths. Now you might ask, what happens in ND? Again, the less than and greater than, if it's less than 1, it lies inside the ellipsoid. If it's greater than 1, it lies outside the ellipsoid. So everything we're learning from 2D, it's very similar in idea to circle. I'm just teaching you this concept so that you have a greater appreciation of how powerful linear algebra is, right? In the n-dimensional space, it's exactly the same thing. It's basically, if you have n-dimensional space, you can say a1 square plus x2 square by a2 square, so on and so forth, xn square by an square equals to 1 for a hyperellipsoid. Such an ellipse in n-dimensional space is called a hyperellipsoid. The same argument of less than 1 implies that it lies within that this point lies, that a given point lies within the ellipsoid. Greater than 1 means it lies outside the hyperellipsoid. All of that just simply flows. So this is what hyperellipsoids are all about. Again, as I told you a little earlier, we seldom use ellipses in machine learning. There may be 1 or 2 places here and there that we use ellipses. We typically use planes, which are extensively used. That's why I spent so much time explaining you planes. And we use circles a lot. Not as much as planes. Planes are used extensively. A little bit of applications of circle. Ellipse very, very seldom used.